طيب, if you recall, gentlemen, we stopped last week in stability. Okay, we talked about stability of a floating bodies, especially like ships, and we talked about three important parameters: center of gravity, center of buoyancy, and metacenter, the metacenter point. Okay, if the ship is stable, that is to say symmetrical moving, M will not be there basically, and we'll have the center of buoyancy just here. Okay, and we said this is the most ideal situation. We said if the ship moves left or right, the metacenter will move from point B, the center of pressure will move from B to B dash, and if you project up, you will actually find the metacenter point. Okay, now depending on whether the metacenter point is far from the center of gravity, close to the center of gravity, or below the center of gravity, there are three scenarios. If M, the metacenter, is far away from the center of gravity, even if the ship tilts left or right, you can restore it by a restoring moment. That is to say, you can turn the ship, you know, the way we turn the cars. But if the ship leans to the left or to the right so much to the extent that the metacenter, look at the metacenter here, okay, came below the center of gravity, that is to say between the center of buoyancy and the center of gravity, the fate of the ship will not be sealed. It will fall on its side. So basically, gentlemen, our criteria is the metacentric height, and there are three definitions here. Please pay attention to them. Okay, what is the definition of the metacentric height? GM, the distance between M dash and G, or GM. So the metacenter is the distance between the center of gravity G and the metacenter M, the intersection point of the line. What is M? M is the intersection point of the line of action of the buoyancy force through the body before and after rotation. The length of the metacentric height, GM, above G, is a measure of the stability. The larger it is, the more stable the floating body is. Right? So this is our criteria. If we wanted to define whether a floating body will survive or will sink, all depends on what? This distance, GM. How do we do it? How do we calculate the distance GM? I said very simple. You have to get the moment of inertia and divide by the volume of the immersed body. It depends if the floating body is a square, triangle. This IOO, we have an expression for it, if you remember. Okay, so you can get CM or GM, the distance GM. Now the distance, this is center of gravity, this is, call it B or call it C, it doesn't matter. So CM, the total distance from the center, the center of pressure to the metacenter, is given by the second moment of inertia divided by the volume of what, guide? The volume of the immersed part of the body. Right? And then GM is equal to CM minus CG. If you agree with me, GM, this distance here, is equal what? Total distance. So you have three distances, guys. You have this distance, sorry, and you have this distance. Right? So CM GM, that is the height we are looking for, is basically equal what, guys? The total distance CM or BM minus what, guys? This distance CG, right? Let us have an example, guys. Let us have an example to explain all this in a careful way. This is a very simple example. A block of wood, 30 centimeters square in cross section and 60 centimeter long. Weight 380 Newton, that is the weight. Will the block float with sides vertical as shown? Right, so you can see a side view and end view. Did you do engineering drawing, gentlemen?
Yes.
Okay. You did engineering drawing, right?
Yes, we did.
So you know what, how to look at to a side view and an end view, okay? Now, what he's asking is, can this floating body is it stable or unstable? That is his question. The most important point that is missing from us is this distance. The body is floating, but how much deep is it going into water? Half, 1/3? Right? So the first thing you need to do, because if you look carefully here, you need to define how much is it in depth, how much has it gone down, the part of the, how much is this part, okay? So that you can define where is G, center of gravity, we know it, right, gentlemen? For example, the center of gravity for this one is known, halfway, right? 15, right? Do you agree with me يا شباب ولا انتوا نايمين? Gentlemen, the center of gravity falls halfway at 15, صح ولا ما صح؟
صحيح.
But how much was this distance? Do you see my cursor, by the way? Do you see my pointer? Now, in order to get this distance, gentlemen, you may agree with me that the weight is acting down and the buoyancy force is acting what? Is acting up, and the two of them are balanced. Am I right or wrong? So basically, your bottom line is FB is equal the weight. The weight is given. The FB is equal what, guys? Is equal the volume of the fluid multiplied by what? Rho of the fluid multiplied by what, guys? 9.81, صح ولا ما صح? Now, if you equate this to this, you will get the volume of the fluid displaced. And because you have two dimensions, you can easily get the third dimension. I mean, how much was it into the water? That is the first point you should do, right? So this is, if you look at it, he's equating the forces. He's balancing the forces. Or basically, the buoyancy force is equal to the weight. The buoyancy force is what? 9.81 times the density times what? 0.3 by 0.6 by d, where d is what, guys? D is this distance. Call this distance d. 0.3 by 0.6 multiplied by D. That gives us what, guys? The amount of the part, the volume of the block that is submerged. And from here we get D equal 18. D is equal to what, guys? 18. Now, second moment of
So-
inertia.
9,810 from where he got it.
ارفع صوتك شويه يا ابني. Just raise your voice a little bit.
9,000 من وين جابها؟
This is rho G. Am I right or wrong? Do you get it?
اوكي تمام.
How did he calculate the volume, Victor?
The volume, okay. The width times the length multiplied by the height submerged, which is D. Clear?
Yes.
يا شباب كويس انكم بتسألوا.
حلو دكتور. keep going.
Keep going. So we got D. Now we know that the amount, the length submerged is 18. Right? So what do we want? We want the metacenter point. We want to get GM, this distance, which is what? Second moment of inertia of the block divided by the volume submerged minus CG. And CG, the good news is we have it. CG is equal to what, guys? The distance from the center of gravity to center of buoyancy. Do you agree with him here? CG is 15 minus 9. That is the most confusing part. So this is the center of, this is IOO, 1 over 12 AB cube, صح? 1 over 12 AB cube is the second moment of inertia about the center of gravity for a rectangular shape. The volume immersed is 18 by 60 by 30 minus CG. CG is 15 minus 9, if you agree with me, because the center of gravity here for this is 18, صح? Halfway of it is what, guys? Halfway of it is 9, right? Now the center of gravity is at what? Is at 15. Center of gravity. So CG or BG is 15 minus 9, if you agree with me. Look at it carefully.
Yes, doctor. It's like
Right.
a machine design.
Sorry?
It's like a lesson in machine design.
Yeah, right. Exactly. So this is, GM comes as what, guys? It's a negative value. That means what? So GM is coming as a negative value. Okay? GM is a negative value. That means where is G, guys? Where is M, guys?
Below.
Below.
Yeah.
This negative value means is totally, because the metacentric height is negative, the block is not stable about the longitudinal axis. Thus, a slight disturbance will make it what? Fall. Okay? Now, the question is also to examine will the block float with side verticals as shown? What if you put it on the other side? Right? So he wanted to examine what? Next, check if the block is stable above the transverse axis.
Doctor, change the second moment of
Yeah,
inertia.
change the orientation of the box. Rather
So
than
30
vertical, put
30
it
square.
horizontal. Okay, now look carefully here. This is the volume, right? And this is second moment of inertia. There is no problem. The distance, the issue is comes for CG. If you put it horizontal, okay, this is 18, right? So the remaining is what? Is 12, right? Sorry, because this is all 30. The part immersed is 18. The remaining is 12. If you put it horizontally, CG basically becomes rather than 15 minus 9, it becomes what? Half of it. Half of the remaining 12. That is 6. If you can imagine it. And not only that, the only thing that comes in is this. And therefore, GM is positive and the block is what? Is stable. Right? A similar problem came in the final exam last year.
Doctor, isn't it 15 minus 9 equal to 6? It's the same.
La. Wait. How much is the submersed amount?
18.
18. How much is the remaining?
12.
12. When you flip it, CG becomes equal to becomes equal half of this, half of the 12. When you flip it the other way around, basically you are having CG is equal to 6. You will have this amount, CG is basically equal to 6 because the floating part is up. Are you imagining it? Half of the 12. It becomes half of the 12.
Yeah, okay. I guess it's half.
Right, so this is, look at it carefully. I know this bit needs a little bit of imagination. You have to imagine it. So these are the two situations, right? And this is, gentlemen, the last point we will stop at. Okay? Fluids in rigid body motions is for reading, is a topic for what, guys? Reading. Because we have done almost this part in a linear motion. Okay? We don't want to go in repeating things in a more complex way. So this topic, guys, is a topic for reading. It is good to go through it, right? It's very good to go through it. It increases your knowledge about rigid bodies if they are rotating, especially that gentlemen, if you go to industry, you know what is this? This is more or less like a reactor. This is more or less like a reactor, or basically what? A device that rotates. Most of the reactants, most of the industries, especially process industry, they have reactants that rotate with very high speed in order to separate different parts of for example, take crude oil. If you rotate it, it gives you diesel, it gives you benzene, it gives you naphtha, right? So rotation in cylindrical container is quite important. It is good to go through it. We are not going to take it as part of the syllabus, but it is a topic for reading, gentlemen. It is straightforward how to get the power and the pressure and so on. out of it. If you want to read it, please, because it might be of interest to you, right? But it is a small chunk. We will not take it into consideration. In summary, gentlemen, chapter 3 has been a long chapter. We talked about pressure and pressure measurement, and we talked about statics and hydrostatic forces on plane surfaces and on curved surfaces, and then we did buoyancy and stability. The only point that we put for reading is what, guys? Fluid rigid body. Up to here, we will say goodbye to chapter 3, and we will go into what, guys? Into the tutorial. You remember, gentlemen, the tutorial for chapter 3? Okay, so this is the tutorial for chapter 3. I will put it on the side for your consideration. Okay, it says question. I will load the tutorial for chapter 3. Okay, and I will expand it a little bit from my side in order to have a clear look. I'm not sure whether you can see my cursor or not. Okay, so it starts from here. So it says question what, guys? For pressure, manometer, and barometer, question 1 to question 12. Question 1 to question 12. Do you see my cursor, gentlemen?
Yes, we
Shabab.
can.
Yes, we can, but we cannot read the.
You cannot read it?
What's it?
Okay.
Yes.
Can I ask you to download it from the Blackboard and open it in your mobile or on your computer?
Sure.
Yeah, download it if you can read it. If I the problem, okay, can you enlarge it from your side?
We can, Doctor. I can enlarge it.
No, you cannot use the Blackboard to enlarge the text. Shabab, can you use the Blackboard to enlarge the text?
I'm
Anyway,
trying,
في
Doctor.
زر في زر زوم اساسا يعني بالجوال يمدي الواحد يسوي زوم كمان.
اي اعمل له زوم، اعمل expand بيوضح معك يا شباب.
ايه.
Question 1 to 12, all of them are theoretical questions, gentlemen, which is basically addressing the theoretical part of pressure manometers and barometers. For example, question 1C, what is the difference between gauge pressure and absolute pressure? 2, explain why some people, forget about it, but this question here basically talks about the three kinds of pressures we have talked about. You have gauge pressure, atmospheric pressure, absolute pressure, and vacuum pressure. You need to understand the relation between them because a question in the exam might come to ask you, what is the value? Okay? Explain why some people experience nose bleeding. This is due to pressure, forget about it. Someone claimed that the absolute pressure in a liquid that is 3 in a liquid of constant density doubles when the depth is doubled. Is he right? We said P equal what, guys? Rho G H. صح يا شباب? This is a very fundamental equation for static applications. So does the pressure double when the depth double? Is he right or wrong يا شباب? If H doubles, will the pressure becomes double?
Come half.
If H initially is 3 meters and then it becomes 6 meters, will the pressure also becomes double or not?
Yes.
It will become double, yes. It's clear calculation, math. Okay, but be careful here. Be very careful. This is correct if and only if you assume the density becomes uniform. صح يا شباب? And also G takes hold at its value, because يا شباب there is modern research which says the gravity G varies with the height and varies with the depth in the water. But if you assume rho G, that is a specific weight, is constant, if you double H you will double P. صح ولا ما صح يا شباب؟ Okay, let us move on. Question 3. It says a tiny steel cube is suspended in water by a string. If the length of the sides of the cube are very small, how would you compare the magnitude of the pressure on the top, bottom, and side? Well, this is straightforward. We have had a look at it. Imagine a cube, and this is the surface of the water. The pressure here on this surface and this surface will be uniform. صح يا شباب ولا ما صح? But on this point and this point will vary. It will increase the more you go down. صح? That is what he's looking for. Express Pascal law, question number 5. Express Pascal law and give a real world example. This question came in the quiz many times in the exam, midterm exam. You know Pascal law, صح? And a real example is the car jack. If you go to the slides, yes, okay. Question number 6. Consider two identical fans, one at sea level and the other on top of a high mountain, running at identical speed. How would you compare the volume flow rate, the mass flow rate? What is the volume flow rate, ya shabab? V dot is equal to what? The velocity time what, guys? The cross-sectional area. And the mass flow rate m dot is equal to what, guys? The density time what, V dot. He is basically asking you to examine these very fundamental relations. Okay يا شباب معايا انتوا؟ So he is saying one at sea level and one in a high mountain. Okay, what do you think about the volume flow rate? Will it be the same? The volume flow rate.
I think yes, it will stay.
You are right. You are absolutely right. The volume flow rate will be the same.
There is no H in the equation.
Yeah. No, the volume flow rate will be the same because the cross-sectional area is the same and the velocity is the same. The issue with the density, as I have just said, the density at the issue is the mass flow rate, because the density at sea level and at very high mountains will vary, if you agree with me. And that brings a variation in the mass flow rate. That is the point. Moving forward. Question number what? 7. It says what? It says a vacuum gauge connected to a chamber reads 24 kPa at a location where the atmospheric pressure is what? 92. Determine the absolute pressure. Be careful. We said there is one relation. P absolute is equal what, guys? Is equal to P gauge, P atmospheric plus P gauge minus what, guys? P vacuum. That is the relation you should stick to. Absolute pressure equal atmospheric pressure. Add to it the gauge pressure, subtract from it the vacuum pressure. And in this case, it was the vacuum pressure. Therefore, the absolute is equal to what? 92 minus 24. Be very careful because this will be examined. Okay?
What said
Let us move
vacuum?
forward.
It's gauge.
Huh?
What it said vacuum? It's gauge.
The absolute pressure is equal what? Is equal gauge pressure plus atmospheric pressure, or atmospheric pressure plus gauge pressure. But it is also equal what? Atmospheric pressure minus what? Vacuum pressure. Am I right or not?
Of course, yes.
Okay, so that is the relation. I told you about it in the, and I told you to make sure you know it very well. Where are we? Manometer. Question 8. Question 8 talks about a manometer, gentlemen. And I tell you something. A manometer is used to measure air pressure in a tank. The fluid has a specific gravity 1.5, and the difference in height between the two arms of the manometer is 28 inch. Since we are talking about inch, leave it. But gentlemen, this is P equal rho GH. Be careful about this relation because this relation will be examined carefully in the exam. Okay? Now, let us talk about question 9. This is this manometer, gentlemen. The water in a tank here is pressurized by air here. And the pressure is measured by a multi-manometer as shown in this figure here. Determine the gauge pressure of air. He wants P1 here. In the tank, if H1 is equal to 0.2, H2 is equal to 0.3, and H3 equal to 0.46, take densities of water, oil, and mercury to be 1,850 and 13,600 respectively. Have we met this or not? This manometer, did we meet it? Did we meet it did we meet this manometer in the slides, ya shabab?
Yes.
Yeah. Do you remember? We said the best way, if you remember, we to approach this from here because this is atmospheric, right? This is atmospheric pressure here at the end because the tube is open. So going down, we said usually manometers, you analyze them what? Going down is positive, going up is what? Is negative. You can move from 1 to 2 or you can move from 2 to 1. If you move from 2 to 1, you have what? P atmospheric plus rho GH3 mercury minus rho GH2 oil minus rho GH2 water equal P1. Similarly, if you go from there, the only issue here is H1 is associated with water and H2 is associated with oil. You be careful about it. Now, I want to tell you something very important. There are many manometers here. There are many. This is one. This is one example of manometer. Okay. If you look down, we have many manometers. We have many manometers. Even go to the review questions. Move down to the review questions. Okay. We are not going to solve. This is a manometer. Go down to the review problems. Go down until page. Absolutely go down. Go down. Go down. Go down. You will find some manometers here. Okay. You will see what? Some manometers here. Okay. I mean, these manometers, for example, last year this manometer came in the exam. The year before this manometer came in the exam. And the year before this manometer came in the exam. Are you listening to me, ya shabab? Ya shabab, can you hear me? Hello?
Yes, doctor.
Yes, doctor.
Yes.
Okay, so
So
what I'm
this
trying to
here,
tell you,
the one on the bottom right.
what I'm trying to tell you, gentlemen, is you need to solve every manometer problem in this tutorial. Leave no manometer question unsolved. Why are the solution, guys? Do you have the solution manual or not? Can you open the solution manual, ya shabab?
No, I don't have it.
Huh?
I do not
Do
have
you have
it,
the
sir.
solution manual? The issue is all these questions are available in the solution manual. Right? Anyone opening the solution manual, ya shabab? Are you opening your mobiles or your computers? If you are logging to Blackboard, can you download the solution manual for chapter 3?
I'm opening from lab.
Right. So if you go to the solution manual, I think it is the solution for this question in particular, for this question here. That is question 9. You will see it in which part, guys? It is question 8, right? Solution is available in question 8. Okay. So there is a solution for it available. Please go through it. Let us go. Question 10. Determine the atmospheric pressure at the location where the barometric reading is 700 millimeter Hg. Take the density of mercury as what? This is P equal what, guys? Equal rho GH. Okay, rho is given, and H is what? H is given. Straightforward. Question 11. The gauge pressure in a liquid at a depth of 3 meters is measured to be 28 kPa. Determine the gauge pressure in the same liquid at a depth of 12. Again, this is P equal rho GH. You will apply it for the first part in order to get the density, and then you apply it in the second part to get the pressure. The gauge pressure of a liquid 3 meters is 28 kPa. So 328 kPa equal rho, which is missing, time G time H, which is given. H is given at 3 meters. From here you get rho, and then you apply it for the second case. Okay. Question 12. The absolute pressure in water at a depth of 5 meters is 135 kPa. Determine the local atmospheric pressure. Now this is again, it says P absolute is equal what, guys? P atmospheric plus what? P gauge. صح يا شباب? This question is about this relation. Straightforward. Absolute pressure in water at a depth of 5 meters is to rate 45. So P equal rho GH. The first is rho GH. And then you have the atmospheric pressure is given. No. You are given the absolute pressure. Right? And the absolute pressure is equal atmospheric pressure plus the gauge pressure. The gauge pressure in this case is equal to what? Rho GH. You have everything. Is this problem clear, guys? Question number 12. Okay. Now he said question number 15. Let us move to question number 15. He said consider a 70 kilogram. Cancel 15, please. Cancel 15. 16. 16. 16, it talks about what? A vacuum gauge connected to a tank reads 30 kPa at a location where the barometric reading is 7,500 millimeter Hg. Determine the absolute pressure in the tank. A vacuum gauge connected to a tank reads 30 kPa at a location where the barometric reading is what? Determine the absolute pressure. The barometric reading means what, guys? Barometric reading means the atmospheric pressure, guys. We said the barometer. Are you listening to me, guys? The barometer basically measure what? The barometer measures the atmospheric pressure. So P equal rho GH, where H is 755, that gives you the atmospheric pressure, right? And you have a gauge pressure of 30, so you add the gauge to the atmospheric to get what? The absolute pressure. That is question number 16. And then he said 18. A pressure gauge connected to a tank reads 500 kPa at a location where the atmospheric pressure is 94 kPa. Determine the absolute. So this is just adding the atmospheric pressure to the gauge pressure to get the absolute pressure. Question 19. The barometer of a mountain hiker. 19 is not with us. Okay, we have 22. Question 22. Determine the pressure exerted on a driver at a 30 meter below the free surface of the sea. Assume barometric pressure of 101 kPa. So you are given the atmospheric pressure, you are given a specific gravity. You can calculate the gauge pressure by what? P equal rho GH. Rho is what, guys? 130. Okay, you are given the depth as 30 meters. So you calculate the gauge pressure, you add the atmospheric pressure to get what? The absolute pressure. That is question what? 22. Is it clear, guys, or you are not following me? Move forward. 28. Okay, says a manometer contain oils, density 850, is attached to a tank filled with air. If the oil level difference between the two columns is 45 centimeter and the atmospheric pressure is what? 998 kPa. Determine the absolute pressure. This is the example where we have that tank. Yeah, Shabab. You remember? So delta H is given, and therefore it is simple, straightforward to apply P equal rho GH. 28, it is basically in the slide. Question 29. Question 29, a mercury manometer density is given, is connected to air duct to measure the pressure inside. The difference in the manometer levels is 15 millimeter and the atmospheric pressure is 100 kPa. Judging from figure, determine if the pressure in the duct is above or below atmospheric pressure. What do you think, guys? I want you to tell me. The pressure in the duct, he said, this pressure, is it above or below atmospheric? From the figure. Hi, Shabab. Can someone tell me, is the pressure above or below? Gentlemen.
Below, Doctor.
He said below. He said the pressure here inside in the duct is below atmospheric pressure. Remember, this is atmospheric pressure here. Because this is open. There is a fluid moving in the duct. There is a fluid moving in the duct. And the manometer shows this shape. The fluid is being pushed up. His question is, the pressure inside the duct, is it above or below atmospheric pressure? One of
No,
your
no, no.
colleagues said below.
No, it's not below.
Huh?
We will adding the atmospheric plus the mercury.
No. From the shape, he's asking you, is the pressure here above or below atmospheric? He don't want you to calculate it. Forget about calculating it. From the figure, what do you think? The pressure inside the pipe, is it above or below atmospheric? يا شباب أنا عندي 25 طالب inside. I have 25 students.
It's above because Dr. by logic.
It is above because it is pushing the fluid. يا شباب, you are right.
Okay.
It is above. Yeah, because if it is below atmospheric, this fluid of the manometer would have gone into the tube. صح ولا ما صح يا شباب? But because the pressure here is higher than the atmospheric, it is pushing the fluid up 15 millimeter. And then you can calculate, determine the absolute pressure. You can simply P equal rho GH, that is the pressure inside the pipe, where H is 15 millimeter, and rho is the rho of the fluid, of the manometer fluid. And then you have the atmospheric pressure is given 100 kPa. So that is 29. Okay, what else do we have? 29, and then he said 30. Repeat the problem 29 for a differential mercury of height 30 millimeters. So if this height becomes 30, how much will the pressure be here? But it is just rho GH. Okay, let us come to 31.
كيف طريقة الحل دكتور 29؟
كيف طريقة الحل؟ P absolute. He want what? He want what? Judging. Okay, that is part of it. Determine the absolute pressure. P absolute equal what, guys? Equal to P gauge plus what, guys? P atmospheric, صح?
The atmosphere.
Atmospheric is given. P gauge is equal to what?
Rho GH.
Okay.
Okay.
Let us move to 30. Cancel 30, please. Sorry, 31. Cancel 31. Go to 32. Okay. Go to 32. He said what? The maximum blood pressure in the upper arm of a healthy person, 120 millimeter Hg. If a vertical tube open to the atmosphere is connected to the vein in the arm, determine how high the blood will rise. Take the density of blood as 100. Huh? How do you measure this? Okay. So the blood inside the human being is equal rho GH is given. H is given. And rho is given. Okay. Now this pressure is above atmospheric pressure. صح ولا ما صح يا شباب؟ How will you solve this, guys? You can calculate the blood pressure if the vertical tube is open to the atmosphere. It's basically, it is like this one here. This problem here and this problem are the same. You are given the pressure here, okay? And you are requested to what? To calculate H. Right? So from here, there is one thing I made slightly incorrect. Millimeter Hg. That means P is equal to what? Is equal to rho G H. Rho is what? Rho mercury, right? And then this is equal to what?
It's equal to P over rho G.
Yeah, yeah, you have the density. So it is exactly like this problem. This problem is exactly like this problem. Please have a look at it carefully, huh? And try to solve it. 32. What else? 32. We are moving into what? 33. Cancel 33. Cancel 34. Or cancel 35. 36 came in an exam before. Okay.
Why we
37 is
cancel them, Doctor?
this one. They are not applicable. They are not applicable to us. They are not applicable to us. Just focus on 36, 37, and 38. 38 also came in an exam before. Now, the solution for these problems is available in the okay, 39 also repeated is also with us. 40 is with us. These are all exam questions. Okay, repeats 41, repeat 40 is with us. Okay, so these are part of manometers. I would really recommend to you guys to go and solve them very, very carefully. If you have any issues, come and discuss it with me. But it is straightforward. Talk, for example, from this. Okay. This is atmospheric pressure. Do you agree with me? Here we have atmospheric pressure, صح? So this is 0.1 and this is 0.2. If you move from here, P atmospheric plus rho GH1 plus rho GH2, huh? Okay, minus rho GH1, huh? minus
Rho GH10 ولا
here you are going from here positive, right?
Yeah.
And then you are going from here negative.
Minus 10.
And this is negative. Air is negative. Air is negative and mercury is negative. If you are moving from here positive, both of these two are positive, right? And then you are going up negative. Do you want to look at the solution, guys? Solution is page what? Let us go to the solution, guys. 38 here. I'm not sure whether we'll find it is 38. Aywa. Go to solution page. Pressure in a natural gas pipeline. Pressure in a natural gas pipeline. Go to page solution 37. If you go to page 21 of the solution manual, question 337, you will find the solution. Okay, solution is available. So please, we are not going to go through them one by one, because if we decided to do that, we will end the end of the time working on these questions. But what I'm trying to tell you here is these questions. Now, 39 is basically 38. 40 is very important. 41 is a repetition from 41. 40, very important. Right? What about 42? Cancel 42. 42 cancel, please. Okay? Cancel 42. Let us move on. He said from 42 is where? 48. 48. 48 is what, guys? is a manometer. 48 up to 52. 49 is a manometer. 50 is a manometer. 51 is a manometer. 52 is also a manometer. Look at it. Right? So these questions, gentlemen, they have their solution manual. You will see one of them in the exam. One of them you will see it where, guys? Where you will see it here, guys? You will see one in where?
In the exam.
In the midterm. In the midterm exam. So my advice is what? Is to leave no manometer problem untouched. Okay? 52. He said then from 52, he said 65. Question 65. We are going into what? Fluid statics, guys. Okay? Now he went to 65. 65? No, 65. 65, 66. Please, can you add 61? Add 61, please. Do you remember where we met this problem? Shabab, are you listening to me? Okay, Shabab. What we did is we analyzed hydrostatic forces on plane surface and on what, guys? On a curved surface, صح? This is case 1 and this is case 2. One of them will come to you in the midterm exam, the second will come in the final exam. Are you listening to me, guys?
Yes.
One of them, if the plane surface came in the midterm exam, the curved surface, a problem in the curved surface will come to you in what? In the final exam. Now, this problem in particular, it is in feet. But if you go to the solution, you will find it in millimeters. Here, it is written in British system. But in the solution, it is written in what, guys? In metric system. I will check the solution. The solution in page what? Let us go to the solution. Solution for this ball. Curved surface. In the solution I have landed for you, it is in page. It is not there actually. Solution for this gate, right, is not there.
So from where we get that?
So what will you do? I think you have to cry. What will you do, Yashba? The solution for this ball gate valve is not in the solution manual. This problem here is not in the solution manual. What will you do, guys?
There's a similar one in the slide.
There is an identical, not similar, identical one. This distance is known to you, is 2 feet. The radius. The total distance is 15 feet. Change them into, but let me tell you something. Forget about this. Look at 62 here. No, 62 is not with us, صح? 61 only, and then we move to what? No, we have from 50, question 53. We didn't do this, 53. 53 until 57. And then move to 61. Remember this question, please. Up to 57. These are with us. These are theoretical questions, guys, about static. Define the resultant hydrostatic force acting on a submerged surface and the center of pressure. This question came in an exam many times. Okay. Someone claims, someone claims what? Someone claimed that he can determine the magnitude of the hydrostatic force acting on a plane surface submerged in a water regardless of its shape and orientation, if he knew the vertical distance of the centroid of the surface from the free surface of the area surface. If this is valid, explain. This is basically, ya shabab, how to derive the equation. Do you remember we derived two equations, one for FR, right? And one for what, guys? For YP, center of pressure. Do you remember, guys, the derivation of these two relations for a plane surface? That derivation, you might see it in the exam. You have to know how to derive an expression for FR, and you need to know how to derive an expression for YP. Right? And this is basically this question. Yes, indeed, you can. If you know the center of gravity, you can. No matter how irregular the shape is, because you are going to integrate around the area if you follow that solution. 55, submerged horizontal flat plate is suspended with a spring. Cancel 55, not necessarily. Okay, question 56. You may have noticed that dams are much thicker at the bottom. Explain why. Why the dam is made much thick, deep at the bottom, not at the surface. Ya shabab. Why?
Because this SG is bigger.
Because of the distance. If you go down, the pressure will increase, ya shabab. صح ولا ما صح؟ P equal rho GH, صح? Okay.
صح.
Right, 56. You may have noticed that the dam, okay. 57. Consider a submerged curved surface. Explain how you would determine the horizontal component of the hydroforce. Up to 57, that is what we said. Stop. 57, also like this question, and we said how to get FR and theta, which is equal to tan minus 1 what, guys? FV of what? Over FH. So basically, the resultant force for both a plane and a curved surface, YP for a plane surface and theta for a curved surface. You need to know how to derive them from first principle. You need to know how to calculate them. Okay, then we come to 61, and then after 61 we move to what? 139. 139. As a matter of fact, guys, I have jumped some questions here. You have to add them. Question 66, question 65, 66. Please add this. This in particular came in an exam before. 65, 66. Okay. 65, 66. And this one is not with us. And here we have this one here. This one here, 75. If it is not added, please add it because it came in an exam before. So please add them. Add 75 and add 65 and 66. Okay. Now this is basically 65 and 66 are basically about hydrostatic forces on plane and curved surfaces. This is, let us read 65, for example. It says the water side of a wall of 100 meter long dam is a quarter circle with radius of what? 100 meter. Determine the hydrostatic force in the dam and it is line of action if the dam is filled to the rim. To the rim يعني full. To the rim يعني شنو? The dam is full. Right? This question came last year in the exam, gentlemen. Okay? So basically you have half a circle like that. This is the dam, quarter circle. Okay? So this is the dam here. This is the dam. This is water here. So if you look, this is the surface. There is no force here, right? But there is a force here. If you complete this, there is no force here, but there is a force here. The force here is equal to 0, but the force here is not equal to 0. So basically, you have to calculate this force, and then what? FH and FV. Okay. Don't forget the water weight. Okay. If you go to question 67 in page what, guys? In page 43 in the solution manual, you will get the solution for this problem. Page what, guys? Solution manual, page what? Page 43, question 367. Here the question is 365, the solution is in 367. Similarly, guys, this problem, please look at it very carefully. Okay? Look at it very carefully. Okay? Similarly, this problem came in an exam before. This problem, look at it carefully. Don't worry about this. Okay? You have to solve this problem. This is a good application, guys, for an external forces. If you look at the curved surface on the outside, and there is a spring here, basically to close the door. This is another type of a gate valve you might encounter in industry. Again, the solution is available in what? 75 question what? The solution is available in is someone checking that is in 377, page 53. Page 53 of the manual. You will find the solution for this problem. Please solve it very carefully. Please solve it very carefully because it came in an exam before. Are you listening to me, guys? Some people woke up and then came and joined. Go to the solution manual, solve it. If you find any difficulty, we can discuss it. The issue here is there is a spring force. So in order to get the forces on the curved surface, you will assume there is no spring. And then in order to get the force on the spring, after you get the forces on the curved surface, you bring in the spring into action and you get the force on the spring. Okay, so that is hydrostatic forces on a plane and a curved surfaces. We are moving into what, guys? Into buoyancy. We are moving into buoyancy. And then in the buoyancy, I said what? 77 to 82. 77 to 82 are theoretical questions. For example, 77, what is buoyancy force? What is buoyant force? What causes it? What is the magnitude of the buoyant force acting on a submerged body whose volume V? What is the direction of the line of action of the buoyant force? These are all questions we have answered them in the slides. I mean, the last part, what is the direction of the line of action? We said the buoyant force acts through the center of gravity of the displaced volume, not from the volume itself, not from the block, from the displaced volume. 58, consider two identical spherical balls submerged in water at different depths. will the buoyant force acting on the two balls will be the same or different? Huh? So basically, if this is the surface of the water here, one ball is sitting here and the other ball is sitting here. His question is the buoyancy force on this ball and the buoyancy force on this ball, are they the same? Hmm?
No, it is different.
Someone said different. Someone said different. Anyone have can oppose him? Hmm? If you say different, why they are different? Why should they be different? What is the definition of the buoyancy force? The buoyancy force says F buoyant is equal what? The volume of the displaced liquid multiplied by the gravity. So this is a displaced liquid, this is the density of the fluid, and this is the gravity. That is buoyant force. So if the ball is here or here, is there any difference in the buoyant force?
No.
There is no difference. The pressure is different, but the buoyant force is not different. If you agree, Ya Shabab, if you agree with me. If you agree with me, the buoyant force remains the same. Unless the density and the gravity, as far as the density and the gravity are uniform, are the same, then the buoyant force will remain the same. Okay, now, so consider identical, number 79, consider 5 centimeter diameter vertical balls, one made of aluminium, the other is made of iron, submerged in water. Will the buoyant force acting on these balls be the same or different? Will they be the same or different, Ya Shabab?
Will be that different.
They will be the same, because
We agree,
the buoyant
it's the
force
same.
doesn't, it will be the same. The buoyant force doesn't depend on the material. The buoyant force depends on how much volume the material, the ball or block, whatever, will displace. Then the weight of that liquid displaced is equal to buoyant force. Okay, let us move forward. Okay, 82, 77 to 82. What is he saying here? 80. Consider 3 kilogram copper cube. Consider a 3 kilogram copper cube and 3 kilogram copper ball submerged in a liquid. The same question, will the buoyant force? Discuss the stability of submerged and floating bodies. This question came in an exam last year. When a submerged body or a floating body becomes unstable. And this is basically the metacenter and the difference between the metacenter and the center of gravity. So that is your discussion will focus on that point. We have been talking about this today. Okay, 82. The density of a liquid is to be determined by an old 1 centimeter hydrometer, sorry, where the division marks are completely wiped out. The hydrometer first dropped in water and the water level is marked. The hydrometer is then dropped in what? In the liquid, and the other liquid, and it is observed that the mark of the water rises 0.5 centimeter above the liquid. if the height of the water is 10 centimeter, determine the density. This is يا شباب exactly the problem of what? Delta Z over Z naught plus delta Z. This is the rho G, this is the specific gravity. Do you remember? For the barometer? This problem exactly is in the slide. This is exactly in the slide. Determine the density. You will determine the specific gravity basically. You cannot define the density because Z naught is given and delta Z is given. Right? Z naught is given and delta Z. Therefore, you can get the specific gravity because the hydrometer basically measures what, guys? The hydrometer measures the specific gravity. And that is the specific gravity for a hydrometer. Now, where are we going? 82 and then what? 84 and 85. So this is the hydrometer, ya shabab. The same hydrometer problem exists in where? In the slides. Okay? 82, 84, 84. The volume of the average density of a regular shaped body are to be determined using a spring scale. Cancel 84. We don't want 84, ya shabab. Cancel 84, please. And why are we 85? Consider a cube. Cancel 85, please. Cancel 85. And then he said, 89, 89, 89, 89. He said the hull of a float of a boat had a volume of 150 meter cube. And the total mass of the boat when empty is 850 kilogram. Determine how much load this boat can carry without sinking in a lake, in a seawater, with a specific gravity 1.03. Lake means what? Lake means fresh water. That is a density equal what, guys? 1000. And the lake and the seawater density is what, guys? 1030. صح ولا ما صح? So the volume, the hull of the boat is 150 meter cube. That means the buoyancy force is equal to what, guys? Is equal raw water, the volume multiplied by what? G. Right? Now, the mass of the boat alone is 185.6. Now, if basically the idea is the buoyancy force should be much more than the weight of the boat. صح يا شباب ولا ما صح? Otherwise the boat will sink. Am I right or wrong? Are you with me يا شباب? Hello?
Yes,
Yes, right.
Yeah, so basically you calculate the buoyancy force. You calculate the buoyancy force and then you compare it, you subtract the weight of the boat, and that will be the maximum extra load the boat can withstand, right? And it differs, by the way, because the raw differ from seawater to a lake, fresh water. Once raw is 1000 and once raw is 1030 kilogram per meter cube. So that is the idea of 89. If you look at tutorial question 3, tutorial chapter 3, it 8 in 89. It finishes in 89, but no, you have to go to the review problem, please. Go to the review problem and add the following questions. There are quite few questions. You have to add them. This question, okay? This question came in the exam before, as it is. This question, this question, this question, this question. add this question يا شباب. Are you with me يا شباب? Forget about this one. Go down, go down, go down. Add this question. Add this question. Add this question. Add this question. Okay, go down. I think that is all. I think that is all. So be careful about the review problems. The review problems, there are quite few of them. This one in particular came in the exam many times. This problem came in the exam many times. All of them are solved. For example, 337, if you go to the solution, 337. Go to the solution page. Which page? Anyone checking with me, Shabab, the solution? Go to the solution page. Aywa. Page 102. Page 102, 103, 104, and 105. You will find the solution for all these questions. Okay? From page 102 to 105. Solution of these questions are there. Please go through them carefully. If there is any difficulty, I'm happy to discuss. But this question is similar to one we have analyzed. And this one is also a vertical, like the car problem. Now, this is all what I can say about chapter 3. Gentlemen, we have 10 minutes to go in order to leave. Okay, what I want from you, if you want, go down to the solution now. Look at these questions. If you have difficulty, we can discuss it now. But this is the end of chapter 3. Next week, we will move into chapter 4. We will cover chapter 4 next week, inshallah. And then the midterm exam might be up to a small part of chapter 4. We will see if we can decide to limit it to chapter 3. But I will discuss with you the midterm exam. The midterm exam is not next week, the week after, right?
Yes, you're right.
Do you remember what time it is? Monday, Tuesday, Sunday?
I think Tuesday.
Tuesday. Daytime or?
4 o'clock, I think. I'm not sure.
طيب. Please, يا شباب. Please ensure that your camera for the blackboard is working, functional. There is a lot of restrictions the management has put, and there is a lot of warning for both staff and students. For both staff and students, not only for students. For us as a staff, we have been told to follow very strict procedures. Therefore, please kindly requesting you to make sure the device you are using, because I'm going to kick out anyone whom I can't see on the camera. Anyone who can't appear to me in the camera, I'm going to kick him out, and then his case will go to the management. So ensure you have a camera on the place of the work and the surroundings. Now I want you to go, guys, and solve chapter 3 very, very tentatively. And if you have any difficulty, please come back to me. Definitely from chapter 1 until chapter 3, the midterm is involved. we will cover chapter 4. Hopefully, we'll cover chapter 4. I'm not sure whether I will cover it or not, but I will try to cover it in chapter 4 is not long. We can cover it in 1 week time. We cannot cover the tutorial, but we can cover the chapter itself. So we'll see whether chapter 4 part of it will go into the midterm exam or not.
Doctor, I think most of the midterm exam will be from chapter 3, right?
Say that again, most of it or all of it?
Most of the questions, I mean.
You will have a manometer problem. You will have a hydrostatic force. You will have a buoyancy question. You will have all these in the midterm.
So piece from each topic.
Yes.
And
then
theory,
from
of course.
chapter 1 and chapter 2, you might have another question.
Okay, hello.
Yeah. But yes, chapter 3 will be dominant. That is correct. Okay. Can I ask you guys to go to the solution, please, and look at this problem, please, in 10 minutes time or in 5 minutes time. Go to the solution, please. All of you, go to the solution page. Go to the solution page 117, please. Solution page 117. Download it from the Blackboard if you don't have it opened. Download it from the Blackboard. In just 7 minutes time, I want you to look at this question. And see if there is any difficulty in it. See how the solution goes, how he calculated the force, because basically he's looking for determine the minimum force F required to open the gate. This gate is hinged from point B, and he wants to push it to open it. How much force? If this is 3 and this is 0.5. You might also see some variations. If you find some variation in the dimension, that should not bother you. Because as I said, there is a variation in the dimensions as well as in the number of the problems. But that should not be a problem. That should not be an issue. The solution procedure is the same, regardless of the difference in dimension or the difference in the number of questions.
Your voice has disappeared, Doctor. Hello.
ايوه يا شباب، ارجعوا للحل بتاع المسألة دي لو سمحتوا.